Okay, so one of your friends raised a good question. Actually, I would like to talk about it a little bit, and then I will continue afterwards. In the slogan example, we said that we create a new slogan with the same object name as we have used here. We had the object, and then we created a new slogan, and then incremented our counter by 1 every time of this object creation, if you recall. So your friend asked whether this is going to create separate objects for each one of them, or since we're using the same variable, same object variable name, what is going to happen? So basically what it does is that you have the object that is initially created for the first slogan, pointing. So whenever I have this object, if you go back to the top of this, so it's a slogan object. Initially, when I define it, it says that it is type of slogan, right? It is a type of slogan object. However, it didn't have any memory allocated for this object. Whenever I call the new slogan, first time it is going to allocate a space for this slogan and then have the corresponding parts in the memory located. However, whenever I create a new slogan with for the same object, what is going to happen is that it is going to create a different memory space for this new object, and then what happens is that now your object will be referring to this new object that is just created. And then another one is going to be created afterwards, and so your pointer basically will be updated to a new address and will be pointing to that specific new location. So that's how it's going to behave. However, as you can see, these previous objects will not be accessible after this point. And that's why whenever you print this object, you can only print the last object's internal representation or toString method. So the previous objects will not be printed at all. So the idea is that these are allocated in the memory, but you don't have a reference that you can reach to. So basically what Java does is that Java uses a garbage collection mechanism. Garbage collection. So this is basically a garbage which cannot be accessed at all. So you don't want to consume memory for these such objects. So you dereference and reallocate this memory for future use. So this is done by the garbage collection of the Java to collect these memory locations. Just a side note, apart from what we have covered so far, once you assign this to a new object, it is going to just update the pointer, but the referenced memory will still be there.
Hocam bu şeylerin referans edilmeyenlerin garbage collection'a götürdüğünü söylüyorsunuz ya. Mesela Java'da dinamik bir süreç tanımlanabilir mi? İşte count her defasında bir counter yaratıyoruz. Counter 1 iken objenin referans ettiği output'u istiyorum diye bir şey olabilir mi? Mesela süreç içerisinde daima bunu track ettiğiniz için counter 1 iken aynı objenin referans ettiği argüman şuydu. Bu zamandaki argümanı istiyorum diye bir şey olabilir mi?
It's always accessing the latest object that you assign to it. So I don't know if it answers your question, but it always shows or points to the last object that you assigned. In this case, it is going to be pointing to this object that we have in the memory.
Mesela aynı o zaman da counter diye bir veri tutuyorsunuz ve counter mesela 5'i gösteriyor. Bu mesela counter'ın 4 gösterdiği zamandaki objenin referans ettiği argümana erişebilme diye bir şey olur.
No, you cannot access the previous variables unless you have another object that points to it. There is no way that you can reach to that memory location without a reference, without an object identifier that you can access through. Okay, that's not possible. At least to my knowledge, you can't do that. Okay, so going back to the rational tester application, if you remember, we have the rational number class. So this is a really interesting example for implementing different operations and constructors. So I strongly recommend you to go over this example and probably do variations and try to implement variations of this rational number. Think of another class which you can implement and try to come up with the design of such a class. is a good task for you to prepare for the exam as well. So you can go ahead and check it at home and try to, implement a similar class for yourself. So aggregation is remember the first type was a dependency. Now we have an aggregation. It is again type of a dependency, but it's made up of other objects that you have within a collection. So if you have a different object that you have been using, then this is called aggregation. So for example, a car has a chassis. So you will have a car with a chassis. So if you have a chassis object, a car will use that object as its part. Such as the example I gave earlier, a student has an address. Address is an object, so it is an aggregate for the student class. So it's going to be using that class object. So you have references to other objects as instance data is how you can identify whether there's an aggregate object or not. So we will see examples of this. It's a special kind of dependency. Aggregate usually relies on the object that compose it. So aggregation it's a collection. For example, as I said earlier, a student object is composed in part of address objects. So you have an address that is specified in the student. So let's go into the student body.java example and see the details of it. Student and then student body. So when you look into the student class, we have, as you can see, we have the public class student, and then I have instance variables, string first name, and then I have a last name, right? And I have private address, which is a different class. Address class is object, home address, and school address, right? So these are the 4 instance variables: first name, last name, home address, and school address. And you have the public student constructor, which is going to basically have the first name as the string, last name, and then type address, the home address, and then type address, the school address. And we're going to just basically assign the name to the first and last name to last one. Home address will be the passed argument, and then the school address will be the school address passed as an argument. And when you look into the toString method, obviously it's just going to print multiple things: first name, last name, the addresses of the student, home and school, followed one after the other one. And this string will be returned as a result. What does this plus equal indicate here? It concatenates the previous string, this one, and adds this at the end of the first string, and then adds this part at the end of the first part again. So it concatenates all those string portions and then returns the string as a result of the toString method. Whenever I call the object with the string utility, it will be calling this method by default. So when you go into the student body example here, we have the main method. So what it basically does is that we have the address class, which is going to be creating in the local variable, the school variable is of type address. So we haven't seen the address class yet, right? So let me show you that too. So this is the address class. When you look into the address class, as you can see, this is the instance variables, street address, state, and then the private long zip code, which is going to basically hold the integer for the zip code. And you have the constructor with this string, street, town, and then you have the what is st? State, and then you have the zip. So state is equal to st, and then zip code is equal to zip. So this is the constructor for address, and this is the toString method, which is basically street address followed by city, state, and the zip code as a result. So when I call the student body, I first create the school address, which is basically the constructor called with all those parameters passed as argument. And then I have the jHome, which is going to be the address that is given here. I have the John, the student John, which is going to have the constructor student with the name, first name, last name, and then if you remember the home address, jHome, which I just created, and then the school address, which is here created at the top. Okay, so I have the John's home address and then the school address. So I'm using the same address for both John and Marcia. I have Marcia's home address, and then I create the student Marcia with first name and last name, remember the constructor. And then I have the Marcia's home address, which is just indicated here, and I use the same school object, school address, which I created before, and use it as in my constructor. So whenever I, print line John, it is going to basically call the toString method of my John object, right? And then within my John object, it is going to call, remember, here I have first name, last name, and then it calls the home addresses toString method, and it's going to call this addresses toString method, right? So it's basically going to so this is, what it prints at the end. So you have the same school address for both John and Marcia at the end of the execution. Any question? So when you look into this, what would happen if I modify the address of the school? What is going to happen if I modify the school address? Let's say I change the school address with a setCity, for example, method, and I update the school address to something else. What's going to happen? Both of these students will have a different school address, since both of them are referring to the school address that is specified earlier, right? So it's going to basically update the fields that are using both in two objects, John and Marcia, as the school address. So this is aggregation. It's using, it's using the address class in student class. So it's basically using the address class and implementing it within the student. So you have an object that is implemented in another one. So in UML, if you remember, this is the unified markup language. UML stands for unified markup language. And I have the student body class, which is using the student class in implementing it. So in student class, I have, before going that, I have only the main method, which returns void. And in the student class, I have the instance variables listed here, and then the toString method. That's the only method I have. And when you look into home address and school address, they're both class address. So it is actually, using this address class, which is indicated by the empty diamond here. So it is meaning that student has address field in it. So the address class again has the instance variables, and again the toString method at the end. Okay, so once you design your application, you would come up with the UML diagram such that it shows the relationship between different classes and different objects that you use in your application. So this reference, what does this reference indicate? It is indicating the current object that this method or whatever method is using right now. So whenever, for example, you are calling object 1 try me, within this method, if you're referring to this means then object 1. If you use this within, for example, object 2's try me, in this case, this refers to object 2. Okay? So whenever you have a this call, that means that it is referring to the object that it is actually running on. So this is important. This reference used inside the method refers to the object through which the method is being executed. What is the main places or the place that you have seen this before? Constructors call. What do we use it for? If we want to distinguish the instance variables with the arguments that are passed to the constructor, we use that in order to distinguish that, right? So I will show that shortly. In the first invocation, this reference refers to object 1, whereas in the second one it refers to object 2. If you have this call, this method call, and then there's a reference within the try me method as this indicates this, in that case that means object 2. In this case that means object 1. So for example here, this is the constructor, as most of you have guessed. This is the most common place that it is used for, but it's not the only place that you will be using. If you have a name, account number, and a balance given as arguments, and then you would like to construct this object based on these arguments. However, also in your object as instance variables, you have the name, account number, and balance. So which name you are referring to? Do you refer to the argument passed or the object's instance? So to distinguish those two, what we use is this parameter. This indicates that, hey, I'm referring to the object that this instance variable will hold. And in that case, this.name, so my object's name field will be the passed argument, which is this one as an argument. Okay? And then this account number, so my object's account number will be equal to the passed argument account number. So if they have the same name, that is how you would distinguish one from another. So next, interfaces. I have given example of interfaces before in the action event, right? Action item listener and all those events and listeners, we have seen the interfaces. So Java interface is a collection of abstract methods and constants. So abstract methods are methods that have only headers but no implementation, internal implementation at all. So it just has the header. So you can declare it with a modifier using abstract, or you can omit it for the interfaces, because in interfaces they are going to be abstract anyway, so you don't need to necessarily write abstract at the beginning. You can just omit abstracts and just write the name of the method, and that will be sufficient. An interface is used to establish a set of methods that a class will implement. So this again gives an idea of a collection of methods that you will be implementing if you ever want to implement that interface. So it just gives an idea of what are the methods that you're going to use. For example, public interface doable is an interface which is going to have any method, any class that is going to implement this interface will have the following methods. So it is going to have a void do this, int do that, and then void do this to whatever those arguments are, and then you have a public boolean do the other, which has an integer argument. So whenever you say I'm going to implement this interface, you say that I will be implementing the details of this method, this method, this method, and this method. All of them I will implement. On top of those interface listed methods, you can add more methods onto your class if you want to. However, you definitely have to include these methods if you're implementing this doable.
Where are these methods defined?
This is defined like this. So you define it as an interface, and then
Where are methods defined?
methods are defined within the implementing class. So if you're implementing it, you define it. There's no internal implementation defined at all in any place. So it's just basically indicating what are the different methods that will be implemented if you ever want to implement this interface. So it just gives a general idea, but no internal implementation at all. Okay? So I will give an example that will make it more clear. So the interface is reserved word, and then none of the methods in an interface are given a definition. So there's no body in the methods of an interface. It's always like this. That's the whole about the interface. You may find this not really useful if you think that you're going to implement it in another class and declare the same thing and just write the internal implementation of the body. Why declare it here, right? Why am I declaring it in an interface in addition to where I'm going to implement it? The idea is, again, to give a general view of the things that you're going to implement. If you're implementing this interface, you always know how it is executing, what are the structure, what it takes as an argument, what it returns. So that's the idea. Otherwise, if you're going to use this interface only one single place, this is not really necessary to do so, right? If this interface is only used once, that means you can just omit this and put everything into that class that you're using it. So after each method declaration, you have a semicolon at the end to indicate that you have another interface method that's going to be implemented afterwards. So several things here. An interface cannot be instantiated, obviously. Methods in an interface have public visibility by default. So even if you don't put any visibility identifier, they are set to public by default. Since they're interface, you want to have public to have availability to see them. And also stating in the class header, you say that I will be implementing this interface. So if you remember, we had the button listener implements, right? Action listener. So we were saying that, hey, I'm going to implement this interface. So you identify it by the implement statement, which is an reserved word for Java. So you can use multiple interfaces in your implementation. So you can have implements button listener, comma, action listener, comma, and so on. So you can implement multiple interfaces at the same time. However, again, the catch is that you have to implement all the methods in every interface that you are implementing. So for example, public class can do implements doable, which we just wrote as an interface. We're implementing this doable, which means I will need to implement all those 4 methods in my class. So I will be having public void do this, which was the exact one-to-one mapping of my interface method. So it's going to map exactly as the original interface. And I will have the internal implementation listed. I will have the second method, and all those 4 methods, I have to have them here. If you're implementing doable, you have to have all of the methods. Any question? And I could have, in addition to this, implement doable, comma, and then another interface. Then in that case, if that second interface has 2 methods, I will have 4 for this doable, and then for the second interface, I will have the 2 additional methods I have to implement for sure. Any question? So implements is a reserved word. Each method listed in doable is given a definition. So you have to define and explain what is done in the application. So let's see this small interface example. So we have a class that implements an interface, and it has other methods in addition to the interface as well. So complexity, question, and mini quiz. Complexity, mini quiz, and then what was the other one? Question. So when you look into this, the complexity.java is the interface. So as you can see, how we define the interface is that it's listed in the single file, which is given as complexity.java, and then I have, instead of public class, complexity, if it is an interface, I just define it as public interface complexity, right? And then in the interface, I only define what are the methods that are going to be listed. You can have constants also defined here, but here it's not shown. There's no constants or variables listed. And in my interface, I have these 2 methods, void set complexity with an integer argument, and then I have an public int get complexity, which is basically the 2 methods that are listed in my interface. Okay, so when you go into the question, as you can see, this is the public class question implements complexity. So it's going to implement the interface. So I will have to have those 2 methods, the get complexity and set complexity methods, in my implementation. So in addition to whatever is going to come from my method calls, I have the instance variables, string question and answer, and I have the private int complexity level. So I have this integer that is going to keep track of my complexity level. I have the constructor public question. I give the query and the result, and it is going to basically assign the instance variables to those argument passed variables. Question is equal to query, answer is equal to result, and then complexity level is set to 1 by default method constructor call. Okay, this is the constructor. So you create a question with the query whatever the question is, and then you also pass the answer of that question. So if you want to compare the answer, you can use that result as a result of the answer. And as you see, the complexity was implementing the interface we had, which was set complexity with an integer argument. So I implemented. Now complexity level equals level. The level assigned by the argument will be copied into my current instance variable. And also we have the get complexity, which is the, again, interface method call we had. So I have return complexity level. Going back to the complexity, so these are the two methods that we need to implement since we are implementing the interface, right? And I have the get question, which is in addition to those two methods of the interface, I have additional methods. I can do that. I can add more methods. So now I have the get question, get answer, and what else is here? I have Boolean answer correct. So basically, it is checking if a user enters a certain answer, I'm comparing with the stored answer. So answer equals the candidate answer. So does it equal to the the answer that I'm keeping in my object or not? So I check that. If it is true, I will return true. Otherwise, I will return false. And then I have the toString method. Again, the idea is you have the two interface methods, and then on top of that, you can have additional methods that you implement. So let's go into the mini quiz. So when you look into this, you have the static void main, the main method. I have two questions which are going to have the question objects. So I have Q1 and Q2, and then the string possible, which is going to be read from the user. So I have the scanner from the keyboard read as an input, and I have the question 1, which I defined as question. I created by the new command, right? I create new question. What is the capital of Jamaica? And then I give the answer as the second argument, Kingston. So it's going to basically create the question 1 object with the question query and then the answer. And I set this complexity to 4 so that this has a complexity of 4. And then I create the second question, which is worse, ignorance or apathy. I don't know and I don't care is the answer. So it's going to set the answer for this one. And the complexity is set to 10 for this question. And you have system out, print, question 1, get question. So you print the question, not the answer, obviously. And system out, print line, you give the level of the question by get complexity method, which was, again, defined in the interface. And I have the user input, scan it with the user's, user's input, and compare my answer to the question 1's answer. Question 1 answer correct, and then I give the user assigned possible answer and compare them. If it is true, I'll print correct. Otherwise, I will say no, and I will print the answer, the correct answer to the question. And the second question does the same thing, and you get the same question and answer sequence one after the other one. Let's compile and execute this. So what is the capital of Jamaica? Level 4 complexity. If I say New York, obviously it's going to say the answer. No, the answer is Kingston, and I will just which is worse, none. So it's going to, again, print no, the answer is I don't know and I don't care. So basically, again, the idea is to use the interface. So you define the interface on a separate class file. So what if I don't have this interface at all? So I just ignore this in the question class, right? So what I do, I just get rid of this implements complexity. Is it going to work fine? Right? Doesn't have any problem. So if I execute this, I will be able to execute it without any problems. So again, the idea is, why am I defining this interface is that I will have a general idea of the implementation of certain features of an interface, and that's where I'm, this is useful in, if you're using it in multiple classes doing the same exact thing. Okay, that's where it is actually useful. If you're using it only for one class, then there's no benefit to it at all. However, if you're consider this fact actually. If you are part of a big company with thousands of software developers, you would like to have a general idea of how things are implemented. In that case, this interface is really crucial and important, and that's one of the features Java provides, and it's really nice to have if you again have a bigger type of applications that you're implementing. Any question? So in addition to the methods, an interface can contain constants, so you can have constants that are defined in the interface as well. When a class implements an interface, it gains access to all its constants. So if it has any constants, it's going to be able to use those. So if you want to implement multiple interfaces, as in this case, so class many things implements interface 1, interface 2. That's what I was trying to say. If you implement both of these interfaces, if this has 2 methods and if this has 3 methods, you have to definitely have all those 5 methods implemented in your class. Okay? So you will have all methods of both interfaces implemented. That's important. So you have many helpful interfaces that are available. For example, the comparable interface, which has the compare to method. Do you remember any compare to method we have seen before? In the string class, which is actually implementing the comparable interface. So it's implementing the comparable interface. If you want to define a compare to method, what you need to do is you will again implement the comparable method and then implement the compare to method within the string class. So you can, it's up to you how to define the comparison. So for example, if you have addresses to compare, how are you going to compare them? Or if you have the students one to another, how are you going to compare? Are you going to use the name as your comparison condition, or are you going to use the ID of the students? So these are all design decision problems. You can either select the student numbers as your ordering values, or you could use the names as your order sequence and comparing sequences for your objects. So it's up to the designer of the class and the application. So if you remember in the compare to, we have the negative, meaning that object 1 is less than object 2. Otherwise, if they're equal to 0, that means they're equal, and if it is positive, it's greater. So when a programmer designs a class that implements the comparable interface, it should follow the same intent, which means, the first object is, if the first object is smaller, you will return a negative value. If the second object is, smaller, you will return a positive value. If they are equal, you should return 0. So that's the general intent in the compare to method, and which you will follow in the same sense. For example, the employee class to order employees by name or by employee number. So which one should you choose? Are you going to return positive or negative? In which case is dependent on the implementation of the method, as I said earlier. So again, the iterator interface. This is also something we have seen before. Iterator is an object that provides, a means to go over multiple collection items, and you can implement this by calling the iterator interface. So it has the 3 methods. What are those? The hasNext method, the next method, and then the delete method. I believe it was the remove method, which removes the object most recently returned by the next method. So you have to, if you want to implement iterator object, iterator interface, you have to implement the hasNext, next, and remove methods in order to correctly implement it. Again, it should follow the same, understanding. HasNext means, is there any other, object that is following? Next means get the next object, or remove means remove the last object that is accessed. So the idea is same as before. So once you implement iterator interface, you have an establishment that that you can access the objects as an iterator, and the programmer must decide how best to implement the iterator function. So you should be designing the has, next, and remove methods by yourself. So you should decide how you would like to access and implement them. And once you implement it, you can use it with the for each loops as we did before. Compared to method, as we said earlier, you can define these methods without actually implementing the interface, as I said earlier. However, formally establishing the relationship between a class and an interface allows Java to deal with an object in certain ways. So you put restrictions to accesses to these methods by providing the interfaces. That's again referring to the importance of interface, right? You could again define these methods without going into interfaces at all. So when you go into the enumerated types, if you remember, we have declared the enumerated types with this fashion. So we have enum season, and then we define what could be the values within this type. So if I define a variable of type season, I will have one of those assigned to my variable, right? It must be one of those values that it is taking. Once you have the time, time could be equal to, how can I set the, for example, the spring? If I want to assign the season time to spring, how am I going to do that? Time equals season dot spring, right? So I'm going to set it by saying that the season dot spring, whatever that type, enumeration type that I have declared. So I will show that shortly. So for example, if fall time is equal to season fall, as it is shown here, so you can assign the assign to a valid valid element of the enumerated type you have in the list, as in the case of this fall time. So you can in enumerated types, you can have a list of values. Also, they're like classes, and we can add additional instance data and methods to that. So we have the constructors that we can define in enumerated types as well. Let's see the season.java and season-tester.java examples. Basically, it's a little bit different than what we have seen before. Season Java and then the season-tester.java. So if you go into the season, so you declare your enumerated season by this declaration. So we have the 4 different types: winter, spring, summer, and fall, with the text assigned to them as given as the arguments here. December through February, March through May, and so on. So you define the enumerated type with the constructor here, and then you have a string span, which basically the season creator, the season constructor, takes the months, and whenever you have the months, it assigns the string that is passed as an argument to the instance variable, the span. So it's going to basically, on top of the instance variable, the months, like the spring, summer, fall, and winter, it is going to also have a span string, which is going to indicate the months that are part of this enumerated type object. So also we have the string return method, which is getSpan. It returns the current month span that we have. So when I run this season tester, it is for each loop. So I have the time variable, which is going to be among the values of the season. So it's going to have the fall, spring, winter, and what was the last one? All of them. And then I have the system out print line, and then I get the time getSpan. So if I execute this, so as you can see, for winter it prints December through February, for spring March through May, summer June through August, fall September through November, and it prints all those dates accordingly. So again, coming back to this is the for each loop. I have a variable that is type of enumerated season time, and it goes from values, which is an iterator that iterates over all the values of the enumerated type season, right? And then for every time I will get the time and then the get span, which is the timeline for the string. So if you go into the season, it is going to print the span of that specific month, as in this case. So what these do actually, what does these do? So these are the constructors. So I create the constructor enumerated type winter. So it calls the season and it gets the string and copies it to the span months. If it is spring, it copies this to the span months. If it is summer, it is going to copy this to here and so on. Okay? So whatever your month is, it is going to correctly have the span that is associated with that specific season and print it on the screen one after the other one. As in this case, time get span will print for all those months one by one. It's going to print the season that it is going to have. Okay. Any question? So basically, you can go over this enumerated types again, since we have seen this before. So every enumerated type contains a static method called values. If you recall, this was a method that we have been seeing, and it's going to have an iterator over all the values that you have in the enumerated type. We use the for loop again. Enumerated type is important because you select the corresponding data range for each variable according to your needs. So enumerated type limits your selection to the fall, spring, winter, and all those enumerated type variables. So it restrains your availability for the variables. So we will be continuing with method design tomorrow, and please again revise the examples we have been covering so far so that you have a better idea of what we are doing here. Okay, see you tomorrow.